Ok. Teste, teste. 1, 2, 3.
ignition. Liftoff. Liftoff. 30 minutes after 8.
Ladies and gentlemen, good morning. It was with great honor that we officially opened the opening ceremony of the 36th Planetary Congress of the Association of Space Explorers, ASE 2025, a truly historic milestone for our country and for the entire global scientific community. For the very first time, Brazil hosts this gathering that brings together astronauts from every continent, men and women who have seen Earth from above, without borders, and who returns to remind us that we are one planet, one humanity, one purpose to care for our common home. Today, we celebrate science, cooperation, and hope, an encounter that transcends languages, flags, and ideologies to show that humanity's true power lies in sharing knowledge and building the future together. Welcome to Brazil. Welcome to ASE 2025. To officially begin this solemn ceremony, we kindly invite everyone to please rise for the performance of the Brazilian national anthem.
Ipirangas, margens plácidas, de povo heróico brado retumbante, e o sol da liberdade em raios fúlgidos brilhou no céu da pátria nesse instante. Se o penhor dessa igualdade conseguimos conquistar com braço forte, eis que eu sei ó liberdade, desafia o nosso peito à própria morte. Ó pátria amada e idolatrada, salve, salve, Brasil nos olhos denso raio vivo, de amor e de esperança permanece, se em teu formoso céu risonho límpido, a imagem do cruzeiro resplandece, gigante pela própria natureza. imenso e esplêndido, ao som do mar e à luz do céu profundo. Fulguras ao Brasil, florão da América, iluminando ao sol do novo mundo. Do que a terra mais garrida, teus risonhos lindos campos têm mais flores. Nossos mares têm mais vida, nossa vida no teu seio mais amor. Com pátria amada e idolatrada, salve salve, Brasil de amor eterno seja símbolo, una garupa sempre estrelado, e digo verde louro desta flâmula, mas no futuro e glória no passado. Mas antes da justiça acaba forte, verás que o filho teu não foge à luta, que tem ninguém te adora a própria morte, terra adorada, entre outras vilas do Brasil, a pátria amada, dos filhos deste sol és mais gentil, pátria amada, Brasil.
Thank you, everyone. The 36th Planetary Congress is an initiative of the Association of Space Explorers, ASE, and we have a special thanks to institutional support, City Hall of São Paulo, Memorial of Latin America, APPA, Secretariat of Culture, Economy and Creative Industries of the Government of São Paulo, Secretariat of Policies for Women of the Government of São Paulo, co-organized by Hardware BR Institute, IBICT, Brazilian Space Agency, organized by Softex, Ministry of Science, Technology and Innovation of the Federal Government, ASC, is sponsored by Unimar. Thanks, everyone. And now, we dedicate a special tribute for those who are the very reason for this Congress, the astronauts. You, who have crossed the limits of the sky, who have floated above the blue of our planet, and who brought us undeniable proof that, when seen from above, there are no borders. Each of you carries in your journey the story of our humankind. You are living symbols of courage, curiosity, and hope. On behalf of the Brazilian people, please receive our deepest admiration, respect, and heartfelt gratitude for inspiring the world. We now begin the official addresses of this opening ceremony. Please welcome to the host of this Congress, astronaut Marcos Pontes. He's the first Brazilian of only South America to travel the space. He's an engineer, military officer, professor, former Minister of Science, Technology, and Innovation of Brazil, and now Senator of the Republic. The word is yours, Marcos Pontes. Thank you.
Ok. Bom dia.
Good morning.
Well, first of all, let's start with this. Everything we do start with a dream. And I remember my time there as a kid. I used to have this dream about flying. I used to go to the airport, see the airplanes there. That was my dream, but I didn't have money for the flight lessons. So talking to the pilots there, they told me, go to the Air Force. In the Air Force, you can have a career, you can fly there. Excellent. But in Brazil, in order to be accepted at the Air Force Academy, you have to pass a very difficult test. You have to study a lot. And besides that, I had to work to help at home. So when I was 14 years old, got my first job. Was an electrician apprentice job at the railroad system there in Bauru, a small city here in this state of São Paulo. And I remember those days talking with my friends that I would like to be a pilot. They told me, you'll be a pilot? This is impossible for you. This is just for rich people. You're never going to be there. Interesting, when you have a dream and talk about your dreams to other people, normally they say it's impossible and such, right? So I got home that day, I was really sad. My mother, she came from work, beautiful blue eyes, Italian. And so she told me, no, they are not right. You can be whatever you want in your life if you study, if you work hard, if you persist, and always do more than expected from you. And she was right. So I did that, I studied, went to the Air Force, became a pilot, and then an aeronautical engineer, test pilot. And after a lot of sacrifice and efforts, I became an astronaut. And then I was in space. I remember exactly the first time after the main engine cut off, poof, took off my gloves. They were floating in front of me. That was beautiful. Pavel was there with me that moment. And that was my dream to becoming reality, exactly that moment. And then I released the seat belts a little bit, look at the small window, and I saw there this beautiful blue planet. And people ask me, what was your first thought when you got to space, when you saw that beautiful planet, right? Well, first thing that I remembered was back there when I was a kid, my friends telling me, you'll be a pilot, this is impossible for you. And then my mother with those blue eyes, the same color of the planet, telling me, you can be whatever you want in your life if you study, if you work hard, if you persist, and always do more than expected from you. And she was perfectly right. Okay, we all have similar stories in our lives. And it's important to realize that today we are here to discuss very important things about the space programs, discuss the technologies, discuss the future of space programs. We all have great jobs, important jobs. We have a lot of responsibilities in our lives. But we shall not forget the way we start. This is important. We can, using our stories in life, we can inspire, and we must inspire a lot of people, a lot of young guys in the future. We have the responsibility to give them a beautiful, nice, great, peaceful planet for them to grow and to fulfill their dreams, right? So, I'd like to thank all of you for being here with me today, sharing this big dream, right? And I see all around, I see a lot of my friends, so we are among friends here. And this is important. I could spend all my time here speaking or talking or nominating all the people, important people here. Though, so let me restrict to some of them that our special guests here. So let's start with Valdemar da Costa Neto. Here he's the president of the Liberal Party in Brazil, and also former representative, federal representative, so with us today here. Our rector of the Aeronautical Institute of Technology. Some of us, we are going there this week as well. Tadeu here with us, also the secretary of our party. The Tel, our vice mayor of the city here, so representing the city. Well, thank you for being here with us. We have so many people, but I don't want to express more here or to extend more the time here. In name of them, and I would like to welcome everybody, all the high figures that are here with us, and everybody here. I know that during this week we are going to have students here. All them are important. Actually, everything is for them here to understand that they can do whatever they want in their lives. If they study, work hard, persist, and always do more than expected from you. Okay, so welcome to Brazil. Welcome to this wonderful and fruitful, I hope it will be the best meeting that we have on the Association of Space Explorers. And for sure, let's make a difference together on this planet. Thank you very much. Thank you. Thank you.
Thank you, Marcos Pontes, for your message. And I apologize, guys, because we have now a special tribute to you, astronauts, and we have a special picture to show you, and I ask you for 1 minute of silence, please. Thank you. Now we invite to the stage the President of Brazilian Space Agency, AAB. Welcome to the stage, Dr. Marco Antônio Chamon.
Hello, bom dia and good morning. I'm Marco Chamon, the President of Brazilian Space Agency, and on behalf of the Brazilian Space Agency, I would like to greet everybody in the name of all authorities already mentioned, military and civilian. I would like to say thank you for you, the reason of this Congress here, for being here. And that for many reasons. First of all, it's very important to us to be reminded of the need of a peaceful use of space. It's part of this Congress. And also remember that the humankind, in form of astronauts, cosmonauts, taikonauts, everybody, is the purpose of go to space for the benefit of the humankind. And you remind us of that. Thank you. Thank you also for this incredible opportunity to give visibility to space activities in Brazil, which is very important to us, makes a lot to us. And finally, and perhaps the most important part, I don't know, thank you for the outreach activities we will perform this week, spread around more than 30 cities, I think, inspiring the youth and not so youth people here in Brazil. That is very important. So, first of all, thank you very much for this great job. And, of course, thank you for the fantastic organization of this gathering here, and particularly thank you for Senator Marcos Pontes, our astronaut in Brazil. We have in our history, we are part of that in our history because of you. Thank you very much. And that's all I'd like to say. It's very important to us for the Brazilian space program and for the Brazilian society have the opportunity to discuss peaceful use of space, discuss the achievements of the humankind in space. So that's it. Thank you very, very much.
Thank you for your message. And to conclude this opening ceremony, please welcome the President of Association of Space Explorers, ASE, an astronaut who flew on 2 NASA missions, served as flight engineer on the International Space Station, and later as the Governor-General of Canada, an inspiring example of leadership, dedication, and passion for science. Welcome on stage, Mrs. Julie Payette.
Good morning, everyone. Здравствуйте, всем доброе утро. Bom dia a todos. Before I begin, I'd like to address a few words to our host, so please bear with me. Antes de prosseguir, gostaria de expressar em nome de todos os astronautas e cosmonautas aqui reunidos, a nossa imensa alegria estarmos neste lindo Brasil por o 36º Congresso Planetário da Associação de Exploradores Espaciais. Gostaríamos de agradecer sinceramente às autoridades, aos patrocinadores e a excelente, extraordinário comissário organizador e, em especial, ao nosso
our
Marcos.
colleague, Marcos Pontes. Someone who, until today, he is so far the only Brazilian astronaut for his wonderful hospitality and reception. You are so great. Thank you so much.
I am here representing colleagues from all over the world for the Association of Space Explorers, and I just mentioned in really, really bad Portuguese how glad and delighted we are to be here in beautiful Brazil, and how grateful we are to the authorities and the sponsors, and to Marcos in particular, for their hospitality and for their heartfelt welcome. So thank you very, very much for hosting us. First time in Brazil. We're really delighted. We are an association which this year celebrates 40 years. And we happen to have within our ranks today 2 of our founding members, Mr. Dorian Prunariu from Romania and Betalan Farkas from Hungary is with us as well. This association was founded at the middle of the Cold War, when the first Apollo-Soyuz mission happened, where there was this first meeting and rendezvous back in space. We are based under the exact same principle of the theme of this Congress. We are here together, not only carrying proudly our flag and our nation and our culture, but we're here for peace, collaboration, and friendship. And this is all this is about. Actually, we saw a picture of 3 of our members, which we lost today. Mark Garneau, who was the first Canadian astronaut. We had Talgat Musabayev, who is a Russian Kazakh astronaut and test pilot, and Jim Lovell, an Apollo astronaut who flew Apollo 8 and the very famous Apollo 13. We miss them dearly. But what we are celebrating, actually, because yesterday, the 2nd of November, we celebrated a very important milestone. On the 2nd of November, year 2000, a crew of 3 people entered the International Space Station. And this was the beginning of a continuous presence of human beings in space. 25 years, a quarter of a century of people working together on board the ISS. It's like a beacon in the sky, telling us that if we make an effort, if we resist segmentation, if we look beyond the national limits, if we find common grounds, and if we decide to work together, we can accomplish incredible things. We should heed some of the lessons of the International Space Station over a quarter of a century to tell us that we can do better, that we can get along. Have you ever noticed that we don't hear much about what's happening in space for the good reason that we are getting along, that we are able to work together without major conflicts, major mishap, and without fighting each other? This we need to continue, and particularly now in these challenging times. But without further ado, why don't we hear from our friends up in space? As we speak, we have 7 astronauts and cosmonauts on board the International Space Station, 3 Russian cosmonauts, 3 American astronauts, and an astronaut from Japan. And they'd like to say hello and to officially open this Congress. Thank you very much.
We express our sincere appreciation for the words of ASE President Julie Payet.
Greetings to all our friends and colleagues gathered for the 36th Planetary Congress of the Association of Space Explorers. From the International Space Station, we are proud to join you in spirit as you begin this very special week in São Paulo. Some of us arrived here aboard the Russian Soyuz spacecraft, continuing a tradition that has connected our nations in space for decades.
And others of us came on the SpaceX Dragon, carrying forward a new era of commercial spaceflight. Together, our Expedition 73 crew represents many nations, many languages, and traditions. Yet every day in orbit, we live and work as one team. That is the true power of cooperation, a power that the ASE family has always understood and celebrated. May this Congress inspire new friendships, new ideas, and new dreams for humanity's journey beyond Earth.
And as a proud member of this international crew, it's a personal privilege to greet my fellow space explorers. And I fondly remember the fellowship of past ASE gatherings, and I know this year will be no different. I apologize for my absence this year and the absence of my colleagues, but we have a great excuse. And to our hosts in Brazil, thank you for your generosity and hospitality in welcoming our community. And a special thanks to my friend, Senator Marcos Pontes, and your most excellent team. From the International Space Station, we send our very best wishes for a successful Congress filled with learning, camaraderie, and the joy of exploration. So from all of us aboard the International Space Station, obrigado. And warm greetings from Expedition 73.
Thank you very much. Now we invite all astronauts for official picture here at the stage, please. Done? Okay, now a photo with your companions. The companions, please come to the stage. Thank you. The 36th Planetary Congress of the Association of Space Explorers, ASE, is now officially open. May this moment mark the beginning of a new era of a global collaboration with Brazil, standing as a symbol of hope, knowledge, and peace. Ladies and gentlemen, we now begin technical session 1, entitled The Brazilian Space Program and Related Technologies. This session presents an overview of Brazil's scientific and technological progress in the space sector, featuring leading institutions that have taken the country to new frontiers of innovation and research. To moderate this session, please welcome astronaut Marcos Pontes, former Minister of Science and Technology, current Senator of the Republic, and the first Brazilian to travel to space.
Cadê a relação deles? Tem aí? você que vai apresentando, né, cada deles. Então você vai apresentando, eu vou dar uma introdução. Okay, now we start the technical section here. This first section is to update the Brazilian Space Agency, so you know what we are doing here in Brazil. We have several presenters. They're going to talk about the civilian part of space program in Brazil, also about the military side with the Air Force here, my friend, test pilots as well. As she is going to present our presenters, I will make some considerations at the end, but I don't want to extend the time. You'll see that we recovered. The time now is 9, exactly the time to start here. And so let's introduce our first speaker.
First speaker, please welcome to the stage Dr. Marco Antonio Chamon, President of the AAB, to share the main guidelines and recent achievements of the Brazilian space program.
Thank you, thank you. Okay, while we wait for the first slide, thank you again for this opportunity to present you some of aspects of our space program here in Brazil. Okay, let me try to gain some time. I intended to give you some bits of our space program. Here is a very consolidated program. We have more than 60 years of space activities in Brazil, but the Brazilian Space Agency is newer than that, around 30 years, 31. And the first slide shows a little bit what we are. We have satellites, developed satellites. We have the Amazonia 1, the first satellite, totally Brazilian satellite here. We have launching capabilities. This is the center in the northeastern part of Brazil, in Alcântara. And of course, we use this space infrastructure to bring benefits for our society in terms of monitoring of natural disasters, in terms of agriculture, in terms of monitoring of wildfires. So that's the main purpose of the Brazilian space program, provide benefits for our society. Next, please. Sou eu que... Thank you. Okay, our mission is, of course, coordinate the space sector for the development of society, and we have 3 points in our vision. We would like to lead the space activity in South America. We have a good point in that. The 2 main programs in terms of developments in South America are Brazil and our natural enemies in football, Argentinians. And we intend to play a relevant role in global space activities, for example, for the use of space activities to mitigate the impacts of climate change. That's part of our purpose. And of course, we are a small program, but we want to contribute to the exploration of outer space. We have some missions in this direction. I will show you in a minute. The Brazilian space program is organized around some particular entities, industry and universities, of course, but you will have the opportunity to learn a little bit more with some colleagues from here that are here. The Brazilian Space Agency coordinate the program, and we have one National Institute for the National Institute for Space Research in charge of the development of satellites and control centers, and the Brazilian Air Force that is in charge of the development of launchers and launching bases. We have some facility spread around the country. In this state, São Paulo state, we have the National Institute for Space Research. This is a picture of our integration and test facilities. We have our launching base. We have, sorry, we have tracking centers, reception centers, and a control center in Brasília, Brazil capital, for the control of many satellites, and particularly our geostationary satellite for telecommunication. What we have already done. So in the Brazilian history for space, we developed launchers, sounding rockets, not yet a launcher. We are working on that. We have two launching bases in the northeast part of Brazil, and we developed some satellites. Some ones are totally developed in Brazil, like Amazonia 1 and SCD, and some in cooperation with other countries. Particularly, we have a very long history with China in the CBERS program for remote sensing. And in 2017, we acquired, with some development in Brazil, but essentially we acquired a geostationary satellite for strategic communications and for defense applications, and was launched from Kourou launching base. For the future, what we intend to do. So we have satellites, we have some developments in terms of rockets, and a lot of applications. And for the future, we intend continuing our international cooperation. Sabiamar is a satellite in cooperation with Argentina. In fact, it's a small constellation, 2 satellites. Each country developed his own satellite. And we continue our cooperation with China with the 2 satellites. The first one, in fact, is CBER 6. We have problems with counting, but the first one is CBER 6. It's a SAR satellite, a radar satellite for imaging, and CBER 5 is a geostationary satellite for meteorology. So we intend to develop, to continue our international cooperation, because we believe it's a very important way to move forward in space. Cooperation is part of our program since the very beginning, and we intend to promote that more and more. The first, here we have our new missions for satellites, but we have new missions in terms of the development of rockets too. So we are updating our sounding rocket with a more powerful development. VS-50 is in development now. First essays was already, first essay was already done, and we intend to use the motor developed for VS-50 for our first launcher in Brazil. It's a small one. We are talking about less than 100 kilograms in LEO orbit, but we are trying to move forward in our developments. And the Encontro launching base, our launching center in the northeastern part of Brazil, is now open to commercial launchings. And the first launcher will be from a South Korean company, and will be launched this month, probably, in a couple of weeks. we will have the first launching of this launcher with some small satellites developed by our universities. So we have things in our radar, things are happening in our program, including this year. And we are now promoting more and more the development of our space industry here in Brazil. Till now, the development of the space industry in Brazil was much more the providers of parts and subsystems of satellites and rockets. Now we are contracting a complete satellite and a complete rocket from directly from our industry. So we are promoting, we are funding directly in the industry a very high resolution satellite, a submetric resolution satellite, and a small rocket. We are talking here about 50 kilograms in LEO orbit, but completely development in the industry, a micro launcher for our own needs. So this is part of our development in terms of promoting the industry capabilities. And we are part of Artem's Accords. We signed the accords in 2021, and we have two contributions, or we intended to offer two contributions to the exploration, lunar exploration. The first one is the Selenita project. The Selenita project is a satellite developed in one of our universities, the Aeronautics Technology Institute, something like that. I see the rector of the institute here, my colleague. And this is a science mission. We are trying to understand the environment in, around the in the cislunar orbit. And we have a much longer in time purpose, that is the development of space agriculture. One day, until 250 perhaps, we will have not one but two permanent lunar bases. One from China, one from the United States, and the countries around these two endeavors. Once there, we will need energy, oxygen, water, and food. And we need to provide that in loco. It's in situ research exploration that we need. The moon is so far that it's not feasible to just transport everything all the time. So we need some in situ developments, and we are trying to contribute to that with the space farming project in Brazil. It's something for 15 to 20 years, but we have here in Brazil a lot of expertise in terms of agriculture. One of the best companies in the world, state companies in the world, Embrapa, is here in Brazil. And with a partnership with Embrapa, we are developing seeds and procedures to use our capability to promote space farming around the world. I think that's it. No, one part that is very important for the Brazilian space station, Brazilian space program, is the education and outreach. And we have a lot of work with children, high school, and even elementary school in Brazil. This is in Brasilia, our headquarters. We have some open gate opportunities for students. And in one of our launching bases, inside a launching base, we have some developments that we use for promote STEM activities. So we have students from schools around the launching base that use this space to understand something about the space. We have a small planetarium, we have astronomical observations, and even they learn how to program a small rover in a simulated environment, something like the Moon or Mars, with some rockets and soil, so some rocks and soil, and the rover needs to navigate in that environment. So this is part of our mandate. We need to use the space to promote STEM and mainly to inspire the children for the space activities. If you need some other information, please feel free to check our space activity program. There is a compact version in English, and this is the QR code that you can use. Thank you very much.
Thank you, Dr. Chamon, our president of the Brazilian Space Agency. And well, as you see, we have several activities going on in the Brazilian space program, and this program, by the way, is very old. It's from the 60s when it started here in Brazil. And I would like to open for a couple of 2 or 3 questions. If you have any questions, please, be free.
I have time for the questions. Thank you.
Hey. No questions, so we go ahead. But before, let me also welcome here with us today our Hungarian ambassador, Mr. Dr. Miklas Haumai. So, thank you very much for being here with us. So, for the next speaker, please. Obrigado.
Muito obrigado. Acho que eu deixo com você.
Obrigada, doutora. Thanks, Dr. Marco Antonio. Continue our program. We will now learn more about the Amazonia 1 satellite, the first Earth observation satellite entirely designed, integrated, tested, and operated by Brazil. Please welcome Dr. Adenilson Roberto da Silva from National Institute for Space Research, INPE, who will present the key results and lessons from this remarkable national technological achievement. Welcome on stage.
Okay. Good morning, ladies and gentlemen. First, I would like to take the opportunity to have a short presentation here about one of important space program from Brazil to a very distinguished people, and thanks for inspiring us and the new generation to continue working on space. Thank you. Okay, Amazonian 1, it was the first 3-axis stabilized satellite that has been fully designed by Brazil. We start this project here as a blank page, and we take a long path until arrive in the result. This is what we get after the first time that we turn on the camera, the payload of Amazonia 1 satellite. It's a remote sensing satellite that has a wide SWAT. The main purpose is for environmental monitoring and agricultural and other application. Just to have a very short summary about here what I want to address, before I enter in Amazonia 1, it's important to know a little bit about what is behind of our design. Here, everyone knows that the qualification, the development of a satellite takes a long time, especially for environmental and system validation. So Brazil decided that we need and we must not work for one mission. We should work in one multi-mission platform that should work as a base, like a truck, that you can have several loads combination. So we decided to work in multi-mission platform. And I will talk a little bit about the design, what we did to validate and provide the multi-mission platform, the launch campaign, and some images. Okay, what is the main purpose of this multi-mission platform? Is to reuse, is not to take a full development, every mission that we would like to have. Of course, we will not cover all the needs that the space program needs, but we want to develop a 500 kilos crash satellite that could work in a several orbit combination fulfill mission requirements. So the concept was focused in reuse. It was a modular design. We are coupling the service module and the payload module, just 8 screws and 2 connectors. So it's almost completely decoupled between both modules. And of course, we need to have capability to fulfill different mission requirements in a very simple and robust design. This was the target. Of course, single point failure free for the function. We do not tolerate a single failure could kill the mission. It's based on a strong equipment heritage. And also, another interesting thing, we qualified mechanically this multi-mission to fly in a different range of launchers, solid ones, liquid, mixed. So this is the design. And also, we developed a lot of equipment subsystem here in Brazil. So the Brazilian industry has worked with us and validated in orbit new design, new development that we could use. I will not enter in detail here, but it's a very typical platform design. So, what is the idea? We can see the bottom part is our truck without the load capability. And the upper part could be the payload. So, the initial design was for 208 kilos only for payload. The volume, of course, depends on the launcher that we select. In that time, the peak power was 900 watts. We could point to the Earth, inertial point, and can work in a several orbit configuration, equatorial, low inclination, polar, and the altitude can be from 600 to 1,200 kilometers. I put here initial. Why? Because now, after developing and following the design, we can provide support for 500 kilos payload and 3 kilowatt peak power for the SHAR mission that we are using. Here is when we start the design, as we do not have a launcher that is able to launch this crash of satellite, we should work in an envelope. And the 5 candidates was this one that we had as a baseline, an envelope for design. But look here, PSLV was not in our candidate, but it was selected for Amazonia 1. And now we are working in Amazonia 1B, that tomorrow, I believe, many of you will visit us in São José dos Campos. Amazonia 1B is being integrated at the lab and should be launched next year. And now the select launcher is Vega-C. So after this very short overview about the multi-mission platform, let's now enter in the Amazonia 1 mission. Amazonia 1 was launched in 28 February 2021. It was really a very hard time. We were amid the COVID-19 pandemic situation. We have been more than 2 months enclosed in a launch base without any outside contact with the people. So what is the characteristic of Amazonia 1 mission? It's in the height, mean altitude, equator altitude, 752 kilometers. Inclination is a sun synchron 9848. Is sun synchron frozen orbit. In local time is 10:30 descending mode. Of course, we use the service model, our platform, and the total mass at launch pad was 638 kilos, completely fully with fuel. It is a fully Brazilian development, as I told you already. And how we arrived there? It's very typical design and qualification process. But here, I should mention, this is the structural qualification vibration test. But in that time, we did not know the rocket that we will launch. So we should work with an envelope of mechanical loads to qualify the satellite. It was really a very, very hard test to fulfill the requirement. Now, the thermal. So this satellite has been designed to be launched during the day. I mean, for example, for sun synchron orbit can be launched to the south or can be launched up the north. That should be a night time. So we are prepared to be launching any situation. Here, of course, is the completely full electromagnetic test, ME and MI and MC test compatibility. And we should also fulfill the requirement with one envelope of launcher with different electromagnetic requirements. Here is just some interesting comment. This is 2 meters by 1 meter. And inside of the satellite, we have around 6 kilometers of wires and around 14,000 electrical connectors. Everyone tests one by one to verify what is going on. Polarity test to check if every connect was doing well. So the satellite rotates, the gyro sense, the computer read, and then command the actuators. And here it's interesting, we have some light on the bottom and on the top. This is the sun sensor that we had to illuminate and check if the solar panel was tracking the sun according to the simulation we did. This is interesting. Is the last test for solar wing deployment just before the launch at the lab, and we will see the same situation in orbit. This is the test. Later on, the real life will show up. Oh, it should have a video here. No, sorry. Okay, the video did not start, but doesn't matter. Let's continue. Here we are already at India in Sriharikota launch base, and this is already prepared 15 days before launch. Now we are going from the system final test to environmental to fill the tanks. Now, completely, the tank is filled, is already integrated with the launch adapter and the launch band interface here, the motorized launch band. This is my last view when I was at the launch pad. So, the satellite was already complete, integrated with the fourth stage, and we had here several secondary payloads. Launch. Now should we have a video again? I hope that it works. Now we are passing for 18 minutes. We just were passengers, like you.
Lift-off normal.
5 seconds.
P3 tracking. P1 tracking. P2 tracking. Stage performance normal.
We will see the fairing open.
F1 separated.
The booster separate. Now the fairing. Separation. Now I have, this is the separation video from the fourth stage of the rocket. It is a pity because we could see the test that we did in lab, and now is. So this is when the bird starts to alive. As I told you, this is 2 days after the launch. We made a lot of checks and then turned on the payload for the first time over a Brazilian descending path, and we got this image without any processing, without anything. This is another very interesting image that we got from the reservoir here in Brazil, from agricultural area in the northwest in Brazil. This is Burkentown in Australia. We got, now we started to check all the system with, including the data recorders. This is another image from northwest of Brazil. Canada, we didn't forget Canada. We took a picture in the, this was timing for calibration the camera. So we had very completely noise and background to calibrate the camera. Okay, my time, I have some minutes. And what is our final comment here? We believe, and I believe, all space program brings a lot of benefit to the society, even directly or indirectly way. Continental countries like Brazil or others, they must have one strong space program. Why? In some areas, it is almost impossible to reach there, to check, to monitor. So this is very important point. Now, talk a little bit about my institute. In our institute, we are a peculiar institution in Brazil because we can start from the mission design, operation, we have space science, my colleague will present some space weather research here, environmental, meteorological, so it's, of course, we are much smaller than NASA and NOAA, but the function is similar to NASA and NOAA, just in one institute. And in the lab tomorrow, you will see that in a building, we enter equipment and deliver satellites to the launch base, completely tested, integrated, and validated. Okay, so talking about a little bit about the multi-mission. So we have, up to now, using the concept of the multi-mission platform, we are in the third mission. First one, Amazonia 1, that is in orbit for more than 4 years with lifetime completed. Second one, Amazonia 1B, that is being tested in launch next year. The third one is the radar, the SHAR, that satellite that is designed together in cooperation with China. So we have completely different missions using the same base, just make some adjustment in parameters and in some actuator, especially because the mass increase. Okay, how we get this? We get this because we work in cooperation with industry, our ministry, AAB, and a lot of people that have been working with us. We had a lot of improvement in all different areas. We complete all the developmental cycle, and Amazonia 1 is already more than 4 years in orbit and working fully operational without any failure up to now, all the system in the main chain. No redundancy was activated up to now. Okay, now to finish, look. This is multi-mission platform, Amazonia 1. Now, Amazonia 1B, the upper part. And here, Fibers 6. All these things are almost exact the same. And we can see that the orientation, Amazonia 1, fly in this way. Amazonia 1B and Fibers 6 will fly in this way, because the payload orientation. So the multi-mission concept has been, in our view, already proved and validated. Thank you, and my time is over.
Thank you, Adenilson. Well, imagine a country the size of Brazil having satellites working effectively here is very, very important. And I'm proud to say that Amazonia 1, which was designed, built, and operated by Brazil, it was launched at the time I was the Minister of Science, Technology, and Innovations here, and I was there watching the launch, and I remember that day very clearly. You were there too. I remember that day when the satellite was disconnected or from the launcher. We got a rotation. And I remember the press that day. Darkton is here too, remember that too? He was there, he was the director of the Space Research Center that time. And I remember the satellite, rotating, and the press, they said, okay, the satellite is lost. No, that was very interesting because right at the beginning, the satellite systems demonstrated that was capable, they were capable of controlling the satellite by themselves, and in a couple of hours, satellite was stabilized and sending very good images to here. So this is important to show that that accomplishment today results in other types of satellites, and we need synthetic aperture radar satellites for several applications here in Brazil, including deforestation control, so getting the criminals before the deforestation so they can look through the canopy of the trees. So it's really, really important. So any questions here? Oh, there's one there. Oh, thank you. Thank you. Let me send the microphone to you here. Could be this one. That be good.
First of all, thanks a lot for the excellent presentation, sir. My name is Thomas Reiter. Can you say a few words about the ground segment? Which ground stations are you using? Is there a central control center for all your satellites? And do you have a central processing facility for all the data? And I mean, how is that organized? Just in a few words. Thank you.
Okay. Yes, we have our main ground antenna complex in Cuiabá, that is a city in Mato Grosso here, and this is located in the geodetic point center of the South America. So in this position, we can cover full Brazil and up to very close to the south in Argentina. This is our main ground station. We have another set of ground station in northwest in Alcântara that is more for telecommand and telemetry. We have also another antenna for reception in Cachoeira Paulista in São Paulo State, close to here. And in Cachoeira Paulista, we have also the data center for processing and store the data. Is the place where is located the supercomputer for climatic forecast, weather forecast, climate change. So the data processing is located there. And for the initial orbit, we have some international ground station because, something wrong might happen. So we did not only rely in the antennas in Brazil, because after leaving the Pacific Ocean, we would lose the contact with the satellite for around 10 hours.
And more? Yes.
Pam Melroy from the United States. I was really taken by the video showing the deployment of the solar array. That is quite unusual video. Where was the camera located? Was it on the launcher, or did you use another satellite to take that video?
The camera for the separation and deployment, it was located in the fourth stage of the rocket.
See, thank you.
Yeah.
Okay. 1, 2, 3. Okay. So, thank you very much. Thank you, Adenilson. Oh, congratulations. And remember, tomorrow we are going to the National Institute of Space Research. So we're going to see there are several of the facilities there in person. Okay? Please go.
Thank you, Dr. Adenius. Now, to conclude this session, please welcome Professor Joaquim Eduardo Costa, also from National Institute for Space Research. Professor Joaquim will present on space weather, a vital field of study for understanding the effects of solar activity on our technological and communication system.
Thank you. Okay, good morning. That was me when I was young. In fact, it's not me, it's Adenilson. Okay, I'll be talking about a little bit about the space weather services in Brazil. Okay, I'm from the National Institute for Space Research, the same as Adenilson. And okay, let's go on. Well, this is the main driver for space weather phenomena, as probably you are pretty aware about. I just put this in all my presentations because I love this SDO image showing you one mass ejection in this red circle. Well, this is the many areas that the phenomena from the sun impacts. For example, surveillance, reconnaissance, communication, navigations. As you know, all the communications using radio needs to cross the ionosphere, and if something comes from the sun and disturb the ionosphere, will disturb this radio propagation, then you have problems affecting georeferencing by GNSS systems. Also, the communication itself can be lost. Navigation system, okay, as mentioned already, in terms of propagation across the ionosphere, the GNSS will give us some big errors. So in this country, it's important, for example, this big land that we have doing our agriculture with this tractor without driver. So we need precise georeferencing. Also drones, also drilling, deep drilling needs this precise referencing. Navigation, air and ocean. Telecommunication, of course, because, again, radio propagation. And, well, this is quite recent. We had in Sweden a kind of problem with the approaching radar for the aviation because the sun did something very funny. It was behind the airplanes landing, and there was a big solar flare, and the solar flare emits radio, or emits everywhere in the electromagnetic spectrum, but radio too, and this causes some jammed radar, and the airplanes were disappearing from the radar. They thought at the beginning that was a hacker, but then they realized that was the solar burst itself. Also, GNSS error again, and recently it was added to some regulations inside the ICAO, International Civil Aviation Organization, for including these variables from space weather for aviation too, because you have this problem of radiation dose, of course, accumulated radiation dose. For example, in flights crossing the poles where you have aurora, beautiful auroras means the particles there in this near the troposphere. And also here in Brazil have the weakest magnetic field over the globe. So this means that the particle trapped by our radiation belts, some accumulation of particles around the Earth that show aurora in the poles, but in the summer region, the South Atlantic magnetic anomaly, that's not Atlantic anymore, is America, its center is in Brazil. The magnetic field passed too near the surface. I mean, this LEO satellite will cross over these radiation belts. And then we have a lot of particle precipitating here too, and then we need to take care about the radiation dose over aviation. In the electrical networks, for sure you know this, in 1989, for example, had a big problem with a big transformer in Canada because of a particle arriving from the sun, get trapped by the earth in this kind of geomagnetic storm we call. Will produce induced currents. Higher latitude is worst, called Birkeland currents, and these will induce currents near the ground, and this will enter these conductors, long-distance conductors like the power grid, and will add some currents in the transformer, hits and burn, and then this gives a very big blackout over the Canada and north of North America. Okay, these are systems being affected. Of course, satellite is the worst problem because they need to travel again, across this fluid called the plasma, that is our upper atmosphere being shocked by this radiation, ultraviolet, soft X-ray, and losing electrons. So we call this plasma, and this plasma, that is the one that is dropped in the radiation beds also, can affect the satellite in many ways, like killing instruments, spikes with the electrostatic charges. Low Earth satellites will have a higher drag because of the expansion of the thermosphere during the storms. Okay, this is a list of possible areas affected by this phenomena coming from the sun, an excess of radiation, excess of particles, very high energetic particles. Okay, some regional characteristics, as I mentioned. This is the radiation belt here near us in the summer region. You can see in this slide here, that we have precipitation particles in the auroral areas, that's normal, the auroras, you know it, but in the summer region, here near Brazil, or on top of Brazil right now, you have a lot of particle precipitating there. Here is a view to show how much this radiation belt compress our area here. And then, just to make sure that I'm not lying to you, this is the single event upset. It's when an instrument on the satellite changes the memory states, like from 0 to 1, 1 to 0. This gives a kind of blue screen, as you remember from Windows. But yeah, if you put all the blue screen or all the single event upset of this satellite, you can see that it maps precisely the summer region. So this is why you have to take care about our land here. Yeah, this is another emissions showing the same in different ways. There is another satellite collecting flux of electrons that you can see that the summer is also again having more evidence of this particle precipitating. This is auroral type. It means this kind of ionogram I used to see in auroral area, but this is the one collected in our area here. So it's similar, the ones in Aurora. And also to mention that we have a lot of air routes crossing this area. This is why we are now studying carefully how much particle is precipitating in the summer region. Okay, how is being discussed around the world? A lot of discussions with a lot of organizations. I'm not talking about there in details, but you see UN copies there. ICAO, WMO, ASE, and a lot of other organizations. We are there discussing together. I mean, INPE is involved since 2008 in this so many forums. And in science, for example, there's a panel, International Panel for Space Weather, and WMO is standardizing these procedures, the best practices to spread around the world. Brazil is one of the 24 regional warning centers that is inside this organization called the International Space Environment Services. And recently, to make sure that we are doing a kind of a cooperation, organized cooperation, there was an MOU signed by these three institutions. COSPAR takes care about the science, WMO is standardizing or distributing the best procedures, and ASE is the one that talks to the end user. So it's the regional warning centers are there. Okay, let's see about the situational awareness. We participated to construct this questionnaire in the UN copies, but we had a lot of other questions, but I selected this one here to see how many countries, 24 responded to this questionnaire, and how many countries has risk assessment including in space weather. You can see 35 was, 15 there is no, but it was planning to have. Brazil is inside this 15 at that time, and it's still. Okay, but many countries today took care about this awareness and make their action plan. And the United Kingdom, some of them are here, not all. United States, New Zealand, Australia. They have this strategic plan, action plan, to who I should call, and a problem is coming, and I have to advise the population of the country. So you have to make these exercises before it happens, to be predictive, not reactive. For example, here, starting in 2012, with White House taking care about that, in US, for example. And well, just to make short the history, recently they also had this cooperation about NASA, NOAA, National Science Foundation, and US Air Force to signing this memorandum of agreement to cooperate to each other in terms of space weather services. And how we are there. Well, as I mentioned, we are one regional warning center since 2008. We strongly engaged in this discussion, not only here regionally, but internationally. We share, well, we vice share 2 of these institutions right now. And space weather in Brazil is not yet included in the National Strategic Risk Assessment. Sorry, we are working on that. Probably the Senator will help us. Good. Space weather security related services, okay? This is my team, or part of it. We had a page as SWIPS, Space Weather and Predicting Center, or all other centers around the world, 24 in fact. And we have a daily bulletin about in English, Portuguese, to talk about this phenomena happening and arriving. This is the satellites we use. Of course, we don't have one yet, but we are planning to have one in the CBERS 5. We're going to have our first payload for space weather. We use this, and some of them are in the L1, in the gravitational balance between Sun and Earth area, to check the parameters from the plasma arriving for the Sun. And this is the ASE and Discovery. The Discovery is not here, but okay, we use this. On the ground, we have a lot of instruments. These are the instruments over Brazil. Well, I'm not going to get into detail here, but this is part of our products. There is the bulletin in English and Portuguese you can access. This is the kind of window we have to work with this phenomena. I used to say that radiation takes 8 minutes. There is no 8 minutes, because when I see, already passed. But anyway, we have the others. Okay, we also work training scientists. This is one of COSPAR meeting that we had here. For example, we had 140 applicants. We selected 30 students from all of these countries. We took 2 weeks to training them here. We also train our civil aviation or officials for the IK regulations. And I guess that's it. Thank you.
Thank you. Thank you, Dr. Joaquim. Stay with me here for a moment. Let me open for some questions. Do you have questions? We have time. Don't worry about the time. Do you have questions? Any questions from the students? We have students here too. Important to have you. Please, there's one there.
Regarding the space weather, I'm surprised you haven't mentioned. Oh, sorry. I'm surprised you haven't mentioned the Carrington effect, 1859, the largest coronal mass ejection recorded in human history. How are we going to prevent damages to our electrical grid when that happens again someday?
Excellent. Well, this is something that the insurance company today is thinking about $3 trillion up to $14 trillion damaging for the planet. Yeah, I didn't mention because some of you probably will visit me tomorrow, and I can give a lot of much more detail there in National Institute for Space Research, where our services is working, is being doing. But anyway, if today you have this kind of storm, probably all this LEO satellite that we, for example, Starlink and many others will disappear because the thermal expansion of the expansion of the thermosphere will slow down, and for the time for communicating with the satellite again to put it again back to the orbit will be too long. We don't believe they will have this time, so they will fail to recover the orbit. Plus, we suppose that the solar energetic particles, the ones that are relativistic protons and much heavier nuclei, will damage most of the instruments of any satellite, geostationary or whatever. So this is why the calculation today is from $3 trillion to $14 trillion in terms of damage. That's why we
I
believe.
express concern because 1859, we just had telephone lines, but even then, the telephone lines were electrocuting their operators. It
was the telegraph.
Yeah, the telegraph. But nowadays, we have much more than just telegraphs. We have the internet. We have a lot more things going on, a lot more wires going on around the planet. It would be much more catastrophic than it was back in the 1800s.
Sure. Let me tell one short history. I got a newspaper from Colombia recently and translated to Portuguese because Spanish is a little bit similar, but not much. And at that time, in 1859, in the newspaper, there was a notice mentioning that everybody went in a small city, went to a church to pray because the world was finishing. And they said that it was seeing some 5 volcanoes in space shining and so on. So this means Birkeland currents that disturb almost every geomagnetic storm, the northern countries like Sweden, Finland, or Canada, with this aurora extending much for higher latitude, they have disturbances in the transformer. But this means the Birkeland currents there is much more strong than the ring current here near the equator. But if they have an aurora near the equator, means that they have a kind of Birkeland currents here. So it's a global disturbance in terms of very high currents induced by this geomagnetic storm. Recently, we had some measurements in New Zealand of about 80 amperes currents. So it's a lot of currents, extra current in the transformer. So this means the sun is capable to do it and capable to do it again. The sun already did it, and the amount of current we had at that time was enough to prove to us that today we'll disturb we'll put it in a dark age if it happens. And recently in 2012, we had one. There is one satellite called Stereo from NASA that is the same orbit of the Earth. It was in the direction of Mars, more or less. One big one like that one hits the satellite. We were able to see how big it was. If it was in our direction, probably we were not here today because it takes normally from 1 year to 5 years to recover if we have this kind of storm again.
Any more questions? There's one. Where? Okay, no. Yeah. Please.
Senhor se importa se eu perguntar em português?
No problem.
Onde, professor? Primeiro, muito obrigado pela...
Thank you very much for your lecture. I was commenting with my colleagues that I had already heard about this work you develop on space weather in a master's program in ITA. I'd like to know if you know that if in your institution there are works with scholarships for MA and PhD degrees in this weather safety and space weather field.
Master and PhD students, yes, a lot of. You're welcome to come.
Yeah. Any other questions here? I have one. We're talking about artificial intelligence a lot. I mean, all the sectors we're working with artificial intelligence. How do you see artificial intelligence helping the systems connected to space climate?
Okay, a lot contribution can be done. For example, we are in the area where the meteorology was working with statistics, for example. We are kind of meteorology in space, right? And you look for the chicken and see if the chicken tells you if it's gonna rain tomorrow. This was a very long time ago. But now artificial intelligence is coming to work in this statistical area, for example, forecasting the solar flare. It's a very complex situation because I need to see some information from inside the sun that will appear in the surface called the magnetic flux that will disturb another magnetic flux. This disturbance will end up in a solar flare or coronal mass ejection. So we are working a lot in terms of using artificial intelligence in the many things, not including my picture or my photography, but including everything that we have to predict the solar flare. Also, not only there, in any other system, because we have to connect what's escaping from the sun to the interplanetary medium that will have another shocks, accelerating again particles, to the magnetism of the Earth, geomagnetic field of the Earth, and then to connect this internally to the ionosphere, and then to the ground, to GIC. So it's a lot of different stages to connect one to the other. If I try to connect in terms of numerical computation only without seeing, will give him nothing. We needed the experts today until today, of course. In the future, perhaps I'm gonna push the button and then we'll see what's happened, but we're using artificial intelligence plus natural intelligence, of course. It's needed also. And that's it. We'll finish the problem, but it will take time.
Excellent, excellent. So, at the end of this part of the section here, before our first interval or first coffee break, I would like to, we have here our three presenters. If you have, again, open again, if any questions for any one of them, please feel free at this time. Please, our astronauts, Commander Bill MacArthur.
First, thank you, gentlemen, very much for your insightful presentations. But Mr. Shimon, I do have a burning question for you. Certainly, we are blessed to have as a member of this organization, your very own Marcos Pontes, the first astronaut from Brazil. Are there plans for a second?
To be completely honest, we have a second astronaut in Brazil. It was Victor Espanha, that was, in a different way, can be considered an astronaut because he flying in a Shepard suborbital flight. So more than 100 kilometers is standard for an astronaut. But your question is about a more permanent program in Brazil for astronauts. We don't have that. We are trying to use the opportunities we have in our international cooperations to promote more and more experiments on board of space stations. That's the main idea. Eventually, these experiments can go with an astronaut or a technical guy to implement the experiment. But it's just an opportunity associated to an experiment. Answer very honestly to your question, we don't have a permanent program for astronauts in Brazil. But we are very interested in use any opportunity to fly Brazilian astronauts associated with experiments, for example, in the space stations.
Solar flares are periodic. When is the next one predicted to happen?
That's good. I mean, in the short term, we don't have much. We have to look to our site, for example, today will tell you you have a high probability to have a solar flare. Solar flares come in cycles, right? Because you need the active regions. If you count them, it's going to give you a cycle of 11 years, roughly. For example, right now it's 150 active regions per month. And over this active region, we can have this instability. And then as soon as we see one active region that has very complex, like we are having recently, I mean, almost every day, it can tell you how much is the probability to do that kind of configuration gives you a M flare or X flare, some kind of intensity of the flare itself, as we measure. And we are having almost every day small flares like C, that's small flare, but M and X, well, we're having a lot, not much. I mean, not so few. We are in the maximum of the 2050 cycle as we number it now, this year.
Okay, so I would like to ask you a round of applause for our presenters here, Dr. Joaquim, Dr. Chamon, Dr. Ednilson. Thank you very much. And again, I come back to our presenter there.
We extend our sincere thanks to all speakers and to our moderator, astronaut Marcos Pontes, for their valuable insights and contributions. Thank you so much for your time. And now we dedicate this moment to say special thanks to all sponsors. Institutional support. City Hall of São Paulo. Memorial of Latin America. APPA. Secretariat of Culture, Economy and Creative Industries of the Government of São Paulo. Secretariat of Policies for Women of the Government of São Paulo. Co-organized by Hardware PR Institute, IBICT, Brazilian Space Agency. Organized by Softex, Ministry of Science, Technology and Innovation of the Federal Government, ASE, sponsored by Unimar. Thank you so much for all sponsors. Okay, we now invite everyone to enjoy a coffee break served in the main foyer. Please return in 20 minutes for the start of the next technical session. So now is 10:15. We waiting for you at 10:35, okay? So the people who use the earphone, you can let on your chair, okay? Thank you very much. In 20 minutes, I see you here. Thank you. event in a few seconds. Please have a seat, and we will start our event in a few seconds. Ladies and gentlemen, please have a seat, and we will start our event in a few seconds. Okay, ladies and gentlemen, as we resume our program, the 36th Planetary Congress of the Association of Space Explorers, ASE 2025, is honored to recognize the presence and the contribution of the Brazilian Air Force Command, a strategic institution for the advancement of Brazil's national space program. The Air Force plays a vital role in ensuring security, research, and technological development, which are the foundation of our sovereignty in both aerospace and orbital domains. We welcome, with respect and gratitude to representatives of the Air Force Command, whose dedication has been essential to strengthening Brazil's aerospace capabilities. Continue our program. Please welcome Air Lieutenant General Sérgio Roberto de Almeida, President of ALADA, Aerospace Projects Company of Brazil. A distinguished General Officer of the Brazil Air Force Reserve, Lieutenant General Almeida has built a remarkable career in strategic management and technological innovation, and now leads one of the companies driving Brazil's presence in the aerospace industry. The topic, please. The topic of his presentation is the new generation of aerospace projects and the paths of international cooperation. Almeida, the word is yours.
Bom dia a todos. Ladies and gentlemen, good morning. Authorities, Mrs. and Mrs. Astronauts, I have to confess that I have a slight envy because we have to consider that all the fighter pilots, one day at least, thought to be an astronaut. Congratulations. We are here to present our new company, brand new company, was created this year, and we have more or less
Since the dawn of humanity, we have looked to the sky with admiration and dreams. Dumont achieved the unimaginable and showed that Brazil, with its vast territory and scientific potential, has always had its destiny among the stars. But to reach them, we must overcome the challenges that keep us grounded through bold and disruptive initiatives. More than 60 years ago, Brazil took its first steps toward space. We invested in launch centers, developed launch vehicles, built satellites, and trained a generation of scientists and engineers. There were good times and bad times. Now, ALADA, the aerospace projects company of Brazil, is born. More than just a company, ALADA is Brazil's answer to reclaiming our place in space. It is an innovative solution that unites the power of the state with the efficiency of the private sector. ALADA proposes a sustainable development model By attracting private capital, the company enables infrastructure investments in exchange for services provided. In addition to investing, ALADA will relieve the federal budget by decentralizing activities from the government to the company, while preserving technological sovereignty in strategic areas. Just as important as generating investment and maintaining technological sovereignty is giving the Brazilian population access to the benefits generated by space technology. The global space market moves billions of dollars driven by technological advances in private investment. Brazil, despite its scientific capability and infrastructure, still takes modest steps in this field. ALADA changes that reality, positioning the country as a key player in the strategic exploration of this expanding market. With a revolutionary impact across all sectors of the economy, ALADA will drive Brazil's aerospace future through three powerful strategic pillars. The first pillar transforms launch centers into commercial gateways to space, using the Air Force's ground and tracking infrastructure to boost technology, investment, and regional development. The second pillar positions ALADA as the central manager of complex aerospace projects under state sovereignty, strengthening national industry and creating skilled jobs. Finally, the third pillar focuses on the commercialization of products and services, offering research laboratories, certifications, courses, and consulting, connecting the state's capabilities to the aerospace market. The future lies above us, literally. The exploration of the aerospace market has a multiplying effect on the entire economy and a transformative impact on our society. ALADA is not just a company, it is the instrument that will take Brazil back to its destiny among the stars. ALADA, de Bagatelle et Astra. Space is no longer a distant dream, it is our inevitable destiny.
Okay, thank you. Just after this brief film, we have to present our goal. Our goal here is to present ALADA's corporate purpose and the strategic pillars. Basically, we were created to explore one new possibility, that is to economically exploit airspace infrastructure and navigation, and activities related to the development of aerospace projects and equipment, and carry out projects and activities in support of aerospace control and related areas. It's quite wide, but we have to consider that before this creation, we had a lot of problems to use the, let's consider the public assets. But in fact, we are more linked with the Air Force assets, because it's possible by Brazilian law to, for the Air Force to sell their service, but it has a lot of restrictions. The price is the cost price. The contract is quite hard to sign because it's quite, there's a lot of bureaucracy inside it. And in fact, we don't receive the profit of this sale. In fact, when we try to find a client to use laboratories or Air Force assets, when they have to pay it, they will pay with a kind of guide that goes directly for the Treasury. And it doesn't come back for the Air Force. It should come back in the next year in the budget, but we have a limitation of the budget, defense budget. In that case, we don't receive for it. In fact, we call it the efficiency paradox, because if you sell a lot your service, you become more poor, because you don't receive money for the use, and you spend money to cover the contract. Then it's not interesting for the public administration to sell the services. For this reason, we will try, by the law, approved by the Senate and the Congress, and signed by the Republic President, a new law that could possibility the company to sell the service with a different price. With a price is the market price, not more the cost of simple cost of the service. And in back, we receive the cost and investment for the equipment. And then it's possible for Air Force or a public laboratory to sell this and to receive for it in the way they can use the money. They can use the result of the service. In that case, this is the new plan, is you have an option for that moment on to sell the services and to use the resources allocating according a plan, a joint plan between Brazilian Air Force and ALADA. We are talking about Brazilian Air Force, but it's not just Brazilian Air Force. It can reach all the public institutions, like, for example, INPE, that present this morning, with an investment plan. As it was shown in the picture, in the film, we have three pillars: the launch service, the aerospace projects management, and the aerospace product and service. Let's start for the last. We have a lot of products and specialized technical services that could be used by the private companies or another countries, for example. And this new company provide a possibility for the clients to access to the state's technological infrastructure, as well as to the products and services resulting from the projects it manages. It reaches aerospace research laboratories, telemetry services, transfer of technology as advisor, because many countries, when they sell a high technological equipment, they have to offer technology, and it's necessary to have a contract of transfer of technology. The company can be one to find a good solution for both countries, for who themselves and who they buy the technology. Advisory in offset contracts, I said, advisory in patents registration, and others. For example, we have a laboratory in São José dos Campos, the wind tunnel. It can be explored by a lot of companies. They would like to use them, but it's difficult to find a contract that would be okay for both sides, for the companies, private companies, and even for the provider. In that case, we create a possibility to sell this services in the wind tunnel. Telemetry. We have radars in Alcântara and in Natal that can follow up the launchings in Cuhu or even in Canaveral. And it's possible to reach to follow the rockets during the launching situation. And it's possible to sell this service of telemetry. So just examples. Transfer of technology, as I said before. In the case of aerospace project management, ALADA operates in the management of complex aerospace projects by attracting clients, partners, and resources, aiming at development of the industry and integration of all stakeholders involved in each project. We used to do market prospecting, investment resources capturing, prime contracting towards industry, and project management. It's just an example because it's quite new for us, but ALADA can be the solution for big projects in Brazil, aerospace projects, to become a possibility as a prime contractor. And finally, and we consider the most important thing, is to launch service. As it was mentioned, ALADA will commercially explore the Brazil launch centers, facilitating access to our clients to ground infrastructure and operational support for the preparation, launch, and tracking of space vehicles and their respective payloads. We will do the market prospecting, the contract dealing, in the launch center's commercial exploration. It was well known that we have problems to find the best place to launch a rocket. And we can offer two possibilities, new possibilities, in northeast of Brazil, Alcântara and Barreira do Inferno. It's a kind of advertising that we are doing because we can offer a new option for the launchers. It's a kind of, this shown clearly the orbital and suborbital launch sites of the world. It was inside this, all the sites, including those that operating, and those was just a dream. It's not operating yet. As it was known, the launch service can be affected by the geographic and geopolitical benefits. It's not just the proximity with the equator that can fuel saving. This map shows the earthquakes in the world. And as you can see, the region of our launch centers, they cannot be reached by an earthquake. It's the same with volcanic activity. It's quite clear that region without any problem of volcanic. Here we can see tornadoes and hurricanes, the regions when they have more possibility to happen. And that part of Brazil, it's normally clear of this accident. And here we can see the traffic, the air traffic. The area we are offering, Alcântara and Natal, they have very few air traffic. And it's not probable for them to increase the traffic because the way to Europe is not by there. It's more or less clear for the increasing of air traffic. For that reason, when you consider that map, and you consider that it's important to have a launcher clear to the, closer to the equator line to save fuel, then we have just these possibilities. Because we are clear of other options, the earthquakes, the volcanic activity, the tornadoes, the thunderstorms, and the air traffic. It's some positions that it's quite useful to launch. And here we see just three sites: Uhu, Alcântara, and Barreira do Inferno. Let's talk about our launch centers now. As you well know, it's important to have a clear area for the launching. And then we consider the orbital planes for the launching, the inclination. And we consider that Alcântara can reach from 2 to 110 degrees. It covers 99% of our commercial orbital planes. And the security area, it's clear enough to receive up to the Category 4 vehicles. It means that it can reach applications in GNSS, meteorology, remote sensing, etc. The other center is a little bit smaller, but it reaches from 6 up to 49 degrees. And it covers 60% of the commercial orbital planes. It means up to, considering the security area that it's a little bit smaller, can reach category 2 of the launching vehicles. Its applications are related to communication, remote sensing, and scientific applications. By that point, we consider that our company is a new option offered by Brazil for commercializing this important sector that is space. And we have one purpose for our company, that is to be the bridge between the private sector and the union's technological infrastructure, facilitating access and ensuring that private companies can use the available resources safely and efficiently. We seek to strengthen public-private partnerships, promoting innovation, competitiveness, and sustainable development, always focusing on transparency, efficiency, and a positive impact on society. Alada wants to be a facilitator. Thank you.
Okay. Well, thank you. Thank you. Thank you very much. By the way, he's from my Air Force class, the Air Force Academy. So we're the same class. So both of us old now. So as you see, Alcântara, the launch center, is located in a very nice position there in terms of angle of flight and also in terms of proximity to the equator. So we have been talking about the center here for decades in Brazil. We're developing the center, and now we have a center operational and, let's say, open for business. So it's this company, the Alada company, is also something that we've been preparing for a long time in the Air Force since 2008. And when I was the minister, I tried to inaugurate this company. Didn't work, but then finally in 2023, we were able to create the company. I was a senator at that time as well, and I had the privilege to sign from the parliament point of view. So I was the one responsible for making this to run there in the parliament as well. A law here in Brazil to congregate all the efforts and activities in the space program, which is very interesting to separate the military and civilian, the public and private. And so we have much more, let's say, on a scenario much better for investments here in Brazil. So, any questions? There's one here. There's the microphone. Microphone is running. We'll be here soon. Okay.
Well, thank you for the presentation. So many of the people gathering here are working with or even been managing companies who may be interested in your offer. Two questions. One, are you exclusive point of entry to those services from the point of view of the state? And the second is, do you have a catalog of what the companies could be interested on?
We have been created very soon. We are quite young. We are still structuring the company. And the idea is to be a bridge, as it was written there, for the public and the private. And in fact, the idea is to offer the services that can be provided by Brazil, the launch sites, the equipments, the laboratories, and things like that related to the aerospace area. Not only space area, but the aerospace also. Then we are not exclusive for this, but in fact, we are more or less the main link with the Air Force. In Brazil, the launch sites are operated by the Air Force. In fact, that's the point. We are not exclusive, but we are the one that commercialize the Air Force assets, and the Air Force has the control of the two centers we have in Brazil.
Okay, any other questions? No, so thank you. Thank you very much. But stay here and we'll come back in the end, at the end. Oh, there's one more? I didn't get that. Okay, there's one more here.
First of all, thank you for your presentation. My question is, as long as a lot is talk about quantum programming, quantum computers, My question is, does Alada has these technologies to offer to the Air Force, the navies, in the Army?
In fact, we have to say that Alada is an office. It's not a company itself to provide the service. We are the link between the public assets, laboratories, and services, and the launch centers, and the private that want to buy these services, these possibilities, this infrastructure. And then we are not the owner of these assets. That's the point. We are just an instrument to contract the public assets.
Okay, excellent. So you have a point of contact here, and so we can talk about that. Let me take this opportunity to thank some of the schools, universities that are here. First of all, the people from the DCTA, Department of Science and Technology of the Air Force. You are here. Please, if you can stand up just for us to see you. Okay. Very good. Thank you. Thank you. Thank you much. University of São Paulo, the State University of São Paulo, Unesp, here. Who's from Unesp? Unesp. Here. A couple of guys here, students. Thank you. Thank you. The HBR, the Hardware Brazil. See you in Hardware Brazil. Thank you. Thank you much. Senai. And Senai, Roberto Monge, Campinas. They're here. Thank you. Centro Paula Souza. Centro Paula Souza. It's not a professional skills education here. Very important to be with us. I also like to take this time to, please, can you project here our sponsors and supporters again? And here. Okay. Also, at this time, as they find there, the sponsors and supporters. Okay, now they're here again. So, again, I have to thank the Brazilian Space Agency, the IBICT, APA, Softex. By the way, Softex. Mr. Rubem Delgado here, please. This one of our greatest supporters here for this to happen. Thank you very much. The Ministry of Science, Technology, and Innovation. So I'm very proud to have the ministry with us here. And the Hardware Institute, we talked about that before, and other, including the Unimar's University of Marília. We really thank your participation here, your sponsorship. That's very important for us. So, can you go ahead? Okay, let's go. So, I was on time.
Now, we have the privilege to announce the Rector of the Aeronautics Institute of Technology, ITA, one of the most prestigious educational and research institutions in Brazil. Please welcome Professor Dr. Guilherme de Arruda Lorenzi. Professor Lorenzi will present the ITASAT-2 project, a collaboration between ITA, ITA, INPE, and the Brazilian Space Agency, which showcases Brazil's capacity to develop talent and create advanced technologies for space exploration. The ITASAT-2 represents a major step forward for national engineering and reinforces our commitment to applied scientific innovation in the aerospace sector.
Good morning, everyone. First of all, I would like to greet you all in the name of our pilot, engineer, astronaut, and Senator Marcos Pontes, and say that I am very honored to be here among people like you, astronauts and cosmonauts, that first of all think in humanity more than in countries or regions. And thank you very much for sharing this moment with you. I don't know if you have noticed it, but I became an astronaut some minutes ago without any training because I was in that photo, that picture. So, as an astronaut, I will say my first words that, Houston, I have a problem. And my problem is my mistake that my presentations is mainly in Portuguese. I apologize for that, as well as apologize for my English in some kind. So, I will, more than talking about ITER in space, I believe I will give you a general overview of what I call a strategic program, national strategic program that has been carrying out for 75 years ago, and I believe we are directing to the next 75 years to the century 22. ITERsat, and I'll show you some examples of satellites that we are carrying out at ITER. And the first one, what was called ITERsat, its mission was mainly to develop human resources for the space area. And the mission was to build an 8 kilograms satellite. ITER was founded 75 years ago, and the main mission was to produce engineers before produce aircraft. And that's, I believe, it's one of the reasons why Embraer has achieved the success it achieved, because the human resources were formed many, many years ago, in spite of the fact that Embraer was founded 20 years after the foundation of ITER. And we have up to now 6, ITER is an engineering school, and a small engineering school, and we have 6 engineering courses during these 75 years. And the last one was the aerospace engineering, which was founded in 2010. And this is a strategic program on space systems, which was defined in 2012, defined ITER as the main academic institution, and our space center was created. And I believe you are about to visit it next Wednesday. So the main reason to build this satellite was to develop human resources, as we did 75 years ago. Due to this special program on space systems, we changed that satellite of 80 kilo satellites into a nano satellite, 6 cubes nano satellites, was integrated in Holland in 2013. And it was launched in the Vandenberg base in California in 2018 with other 64 spacecrafts and more than 35 customers. So this is a small roadmap of what we have been conducting at ITER, dealing with satellites, initiating in 25 until this launch of ITERsat in 2018. After that, we understood that we were required a little more mature, and this project called Sport was set in order to deal with some plasma bubbles and space weather, as was well showed us by Professor Joaquim da Costa. These are some of the problems we were intended to discuss with this project. SPORTS stands for Scintillation Prediction Observations Research Task, and it was initiated in 2018. It was a CubeSat of 6U and involving NASA, INPE, ITA, DCTA, which is our Science and Technology Department of the Air Force. Mainly dealing, as I said, with plasma bubbles. This was the handover of the export in July 2022. And the launch of Spot was set in November 2022. This is a photo. It was launched from the International Space Station. And here we see on the roadmap, I will try to reach the next century. And we are now dealing with two other projects on small satellites, always dealing with academic purposes in order to develop the human resources which will work on our industry, on other segments of this industry. Selenita, as was said by my colleague Chamon, is on the Artemis program, and we are responsible for the satellites, and the main mission of it is to study magnetic fields in the moon. This is our project. So the main purpose is to study the lunar electron and ion analyzer, dust experiments, magnetometers, boom, and ionizing radiation detector. The project is on its way in terms of mechanical projects, electronic projects, all the projects related to the small satellites in academic use. So we have also had in last year the visit of the South Cone in order to know the projects we were carrying out at ITA and to improve the relationship between Brazil and the US, especially with NASA. This was already set by Professor Joaquim. Some of the problems we understand we are about to study with these small satellites, mainly dealing with space weather and the region where Brazil is located, which demands some worries about these anomalies. I insisted that the purpose of our projects and satellites is to develop people, developing human resources to further work on our industry. Once again, some of the problems, localizations of signals, and the impact on the satellites, on the radars and in communications antennas. We have, talking about ITASAT-2, already a preliminary design signed, and the main partners are NASA, US South Cone, Utah State, and Naval Research Laboratory. This is a view of conception of ITASAT-2 and the conception of 3 satellites. As I said, this is not technical presentations, but I would say a strategic presentations of what Brazil can deal when talking about space. I remember after 75 years of its foundation, we could provide the industry, in particularly, people who would carry out the development of the aeronautical industry in Brazil. So we believe that for the next 75 years, we can also make something like that, talking about space. So those 6 courses that were created during 75 years, we are about to create 3 new courses in Fortaleza. It's our first campus of ITA outside São José dos Campos. It will be located in Fortaleza, which is, I would say, 4-hour flight from São José dos Campos. And there, we will have 3 new courses: systems engineering, energy engineering, and bioengineering, which I believe that are strongly related to space, although it can seem something different. But systems engineering in particular has much to do with space aspects. So, ITACET has allowed us to develop human resources for the space area. Sport has allowed us to study space weather in terms of academic. Selenita will be our first missions to the moon. And ITASAT-2 intends to continue the missions talking in studying aspects of space weather and localization, signal localizations. And we believe that this new campus of ITA located in Fortaleza will allow us to, talking about engineering systems and energy systems, will allow us to improve the development of new human resources for use in the space. So, as I said, we took 75 years up to now, and we believe we have given a huge contribution to the establishment of the aeronautical industry in Brazil, talking mainly about Embraer, but we can find initiatives of aeronautic all over Brazil. Yesterday, we had a meeting of students in São José dos Campos with more than 60 universities dealing with development, designing of models of aircraft from north, from south, from Midwest. So I believe we are on the way to have in Brazil for the next 75 years also the possibility to establish a complex of industries, of institutions of development to build also here the same success we had in aeronautics as in the space. That's what I was supposed to talk to you. I hope if you have any questions, I am at your disposal. If the question is easy, I will answer. If it is difficult, I will ask my beloved wife to answer. Please. Thank you very much.
Thank you. Thank you. Thank you very much, Professor Lorenzi, rector of my university. I'm really proud to be a part of this university. It's very important for the development of the technology here in Brazil. And we have former students all over the world working in technology, which is really, really important. So, any questions? Questions? Anyone here that would like to go to ITA? The students? Yeah, there's one there.
Is it an easy question or a difficult question?
So, André Amarante from São Paulo State University. I'm just curious about the Selenita mission. What kind of type of the orbits do you will have? Something like the low orbits or high orbits?
It's supposed to 500 kilometers to 370 kilometers.
Okay, thank you so much.
One more question here.
Yes, please.
Here, yeah, there.
Я не буду говорить по-английски, потому что, возможно, вы не поймете мой английский, поэтому я вас спрашиваю по-русски. Обязаны ли ваши выпускники по окончании университета отработать несколько лет именно в Бразилии? Они просто вы воспитали умные, сильные кадры, а они выпорхнули из Бразилии, уехали, и вы опять ни с чем остаетесь.
We need the translation. Okay, just a moment for him to get the. That's here. Oh, yeah. Okay. Please, the translation from Russian. Yeah, into English or Portuguese. Непонятно. Okay. Number one.
Marcos, may I help you? Here. May I help you? So the questions was about the students when they graduate the institute. Are they obliged to stay in Brazil and to work for Brazilian companies a period of time?
If you're going to...
If they graduate from an institution, higher institution, are they obliged to stay and to work in Brazil a period of time, or they can leave the country instantly?
Okay, then.
No, they are not obliged to stay in Brazil, although we would like very much to stay, but there is no obligation to stay. That's, I would say, a good thing that Brazilian Air Force allow to our citizens to have a good formation. But
by the way, it's not even obliged to stay in the Air Force. This school is maintained by the Air Force. And a couple of the students, they go to the military. They keep working inside the military as engineers. And others, they choose to be civilians, and they can work anywhere. So it's good. It's like a social contribution from the Air Force for the country. Any other questions? Okay, there's one more there.
Olá, professor. Realmente é motivo de muita honra o ITA para todos nós brasileiros. Mas falar do ITA sem esquecer
without mentioning an important name, our senator and astronaut Marcos Pontes. But we have Osiris Silva as well. And I'm curious, because I follow ITA's history for such a long time, what's ITA before and after Osiris Silva? Because we have here our aviation industry, which is known all over the world and has a strong history linked to ITA and Osiris Silva within that context. So you, as a representative, of ITA today, what does that represent for students, all this history? Because Brazil, unfortunately, does not cultivate its history, as Winston Churchill would say. A people who does not cultivate its history, its fate is to repeat it. And I'd like to know if inside ITA they are proud of the history of these men as...
My name is Mol. Mike Oscar Lima, controlador de voo da Força Aérea.
Thank you.
I'm a flight controller from the Air Force.
At ITA, the name of Colonel Osiris Silva, which was the founder of Embraer. Of course, we consider it very, very much, not only him, but many people who has contributed to the building of all we have in Brazil when we talk about aeronautical engineering. ITA has, in fact, 4 honoris causa doctors, if I can say that. The first one is Alberto Santos Dumont. The second one is our founder, Marshal Casimiro Montenegro Filho. The third one is Colonel Osiris Silva. And the fourth, which was, the title was given this year, is Dr. Fernando Mendonça, which is the founder of INPE. So if you think that in 75 years we have 4 honoris causa doctors, and one of them is Colonel Osiris Silva, you can imagine that the whole it played in our history. Despite that, I also always try to remember those people that contributed to this, to what Brazil is nowadays in terms of aeronautics, but they are unknown. Many engineers, many researchers that we do not know their names, but they played a very important role also. But specifically, talking about Colonel Osiris Silva, of course, we have him as a very important person. And it will be given to him on the beginning of December in Italy, a special medal recognizing him as an important person in all we talking about aeronautics in Brazil. Thank you for your questions, very important.
Thank you, Professor Lorenzi. Thank you for your contribution. And there's one more question there at the end. Yes. Mario.
Thank you for your presentation. I'm going to ask you to clarify something, because I think in your presentation you said you were going to have the satellites, the CubeSats, around the moon to study the magnetic field of the moon. And as we all know, there's not a global magnetic field on the moon. So can you clarify that for me? I think I understand, but maybe some of the others in the room don't. I would ask that.
Well, I think you understood correctly, but I think I cannot clarify more than that, because it's a very technical aspect. But your understanding of what we are supposed to do is that, to understand the magnetic fields in the moon and how it works, but always together with other institutions like NASA and some US universities. But the projects and the missions are, I believe, still being clarified. But your general overview is correct.
Okay, because what I'm thinking your intention is, the geology on the moon has local geologic residual magnetic fields. So there's not a global one. So I just wanted to clarify that.
That is different from the Earth. The
yes,
magma,
very much.
The magma is different from here, so it's supposed to be studied by our academics. Remembering that our purpose is always academic. So it's first step towards some more detailed studies.
Okay, so we are on time here. Thank you. That is exactly on time here. Thank you very much, Professor. And congratulations, congratulations. Let's go to the next panel. Next presenter.
So now we will invite the Chief of Staff of the Space Operations Command, COPE, who will present the Center's strategic role in the monitoring, defense, and operation of Brazil's satellites. Please welcome Air Major General Rodrigo Alvim. The COPE is the backbone of Brazil's space management and control, ensuring security, efficiency, and integration between civil and military activities. In Major, the stage is yours.
Thank you. Ladies and gentlemen, thank you all. I'm very happy to be here. Our Senator, thank you for the invitation. As the General said, I also have my dreams. I'd rather be seated among you there, but here I am. By the way, I'm still dreaming of, who knows that? So I'm here to bring the contribution of the Air Force for the Brazilian space program. And first of all, I'm here in the name of my commander, General Barbakov, who is the commander of the Aerospace Operations Command. So we are responsible for employing all the Air Force assets, including aircraft and space. It's not by chance that we had those three blades together here, the academic side for the formation of our engineering, the company that will open the doors for the private and commercial companies, and the government, which by my side is represented by the Air Force, pushing the development on the Brazil. A little bit history, so you can understand the whole picture of putting this thing together. We started early, on the 60s. This decade, we founded the launch center in Natal, and Brazil founded the INPE that you heard of on the 70s. And we founded the Alcântara launch space on the 80s. But due to several events, we didn't succeed until nowadays to have our own rockets to launch the satellites. We had budget problems, and we had a huge accident. Unfortunately, we lost 21 men on that accident. So in 2012, the Air Force turned and took a different way. So we created this commission. Those letters stand for Commission for Coordination and Implementation of Space Systems. And we changed for explore our assets, our resources, and combine it with the private and commercial initiatives. So we made the strategic program, and we passed it to the Ministry of Defense. So since that date, we started to building the Alada company, and we start to have a strategic program for the Air Force. We used to say the Brazilian space program is divided by the civilian efforts, the national program for space activities led by the Brazilian Space Agency, and the strategic program for the space systems led by the defense side, the Ministry of Defense and the Air Force. We had last year approved a space law in Brazil, which reaffirms that. We had two space authorities, the civilian authority and the defense authority, working together to have the Brazilian space program. Our strategic program is led by the Brazilian Air Force. We aiming to have our sovereign access to space and the operational autonomy of national space systems. Our objectives is to ensure the dual use, civil and defense capabilities. The Brazilian Air Force has a strong DNA having the dual systems. For example, we have the system who controls the air traffic is both civil and for defense purpose. So we have more coordination and economy. We want to support the network-centered defense systems. Of course, we have to be strong in command and control. And another objective is to strengthen Brazil's defense industrial base. So as much as we can, we'll be happy strengthening our own industry and promoting SSA and SDA, Earth observation and security communications. So that way we can protect our assets, both civilian and military. Of course, it's structured like this one in the 4 segments. I'm going to talk about each one, the users, the vehicles, as you already seen, the space segment, the satellites which we are trying to push on. We don't have still satellites made in Brazil for defense purpose, and neither we don't have still launch vehicles made in Brazil. And the ground segments. The near future we are aiming of are those systems for communications. We already have the geostationary satellite. It's a dual use. It's a joint between the Air Force and the Telebras company, which belongs to the Ministry of Communications. For Earth observation, we have a couple of satellites for radar imaging, but they were bought, not built in here. And we are aiming to have this optical also. The launch vehicles, it was already showed, the VS-50 and the micro satellite launching vehicle. They are under development. And the space objects monitoring system. So we are putting a lot of effort to have this radar and telescopes to contribute with the community, being a country that provides data. Those are the two mainly areas of employ we have. So when the Brazilian Air Force is trying to lead the imagery, getting, processing, and distribution among the government and other agencies, and also for security communications, as I said, both civilian and military. The civilian communications, it's running by the government company, that's Telebras, for the civilian purpose. Since we are a huge country, we need to ensure all the regional connections. We had this huge flood problem last year. I think 184 people died last year because of those floods. And this is an example of what we can do. We can offer this monitoring using the radar images and also optical images. So we can ensure a quick response to help the people. There were a lot of people isolated from help, from food, from communications. So we could provide them with emergency aspect and also rescue them to help the people. So we are trying to enlarge this capability and also with contact with other countries in South America to make those kind of agreements. Other thing that we use as a huge country and we have this regional problems, we use also our user segment to help countering illegal mining operations. So we are developing using IA to find those equipments they use for illegal mining. So that's another example of a problem then we share with our neighbor countries and we can cooperate with them. For the launch segment, you already showed the next step for the Brazilian Air Force, which is using our launching center for the companies. And that will provide us better resources to have our own projects. This is the next step. We downsized a little bit our program. In last decades, it was a larger vehicle than that, but now we are aiming that microsatellite launch vehicle. For space segments, we are helping the Brazilian industry to nationalize the payloads, and with the support of the Ministry of the Science, we are trying to implement our own constellation of optical satellites. So those are the projects we are aiming in the future. For the ground segments, this is our Space Operations Center. As I said, it's a joint contribution between the Air Force and the Telebras company. Here we monitor and control all of space assets that are in charge of the Defense Ministry. But also we can assure the safety and provide the monitoring for all the assets in Brazil. And we are increasing our regional cooperation with other countries and with our allies. So we have a cooperation with Colombia, for example. We have one Colombian officer working here in Brazil with us, and also US officer from the Space Force in the US. So we seek to expand our cooperation initiatives. We are growing so much with those experiences that we are trying to catching up the leading countries in the world in SSA, in SDA. And we are succeeding to do this. The other mainly thing that we are doing is our participation in the Global Sentinel exercise. So we are developing our skills to help the international community to provide this SSA capability and ensure the safety of the space operations around the world. And we are aiming to have our own sensors as soon as possible. Other than that, we have been participating on the same level with the other countries. So we are trying to do this kind of effort to have this collaboration agreements to do formation and capacitation, and also academic partnerships and joint exercises to learn from each other. And we are constructing bilateral or multilateral security cooperation agreements. We already have those agreements with a few countries which we have relationship. And we aiming to be leading on South American space consultation mechanism for regular dialogue. This is an example of we can offer to our neighbor countries. We can share images that we have. We can have this common operation of the assets the neighbor countries have and then we have also. And we have the capability to offer the strategic communication. Our satellites can offer, for example, in natural disasters, we can provide communication for all the countries from south of US until the South America. So this is my last slide. What is the strategic importance for the space for Air Force? We are trying to catalyst the space sovereign innovation, like providing the Brazilian companies the means they need to develop themselves, to develop the systems here in Brazil, to have all the chain here. We aiming to be able to build the satellites and to launch them in our territory. We have shared challenges with our common problems between our country and the neighbor countries. So we have to focus on border security, connectivity gaps, and disaster response, as I told you. And the Brazil's vision is to evolve in the national autonomy into a regional integration and share the capabilities with other countries. So we are committed to transparency, mutual support, and capacity building. So that's what I brought for you today. Thank you very much.
Thank you. Thank you, thank you, thank you very much. I have the pleasure to say that we used to fly in the same squadron in south of Brazil. It's really, really good to see him here now with so many important activities inside the Air Force and for the space program here in Brazil. Any questions? No questions? Okay. So, there's one over there. Please.
Senador, eu não sou tão velho não, quase 80 anos, mas eu acompanho o programa espacial no Brasil desde o CNAE. Essa base de lançamento de Alcântara, de Barreira do Inferno, fui eu quem desenhei, junto com os coronéis na época, que aguardavam o desenho para voar no Beechcraft por 8 horas, chegar em Natal, tinha terraplanagem para começar a terraplanagem das 3 classes de lançamento. Eu estava no CNAE nessa época, em seguida foi o INPE, fui diretor industrial da Avibras, e posso dizer para o senhor que a gente está precisando de um puxão de orelha no Brasil. Por quê? Os programas todos são de governo, não são de Estado. Cada governo tem sua predileção, manda mais verba, menos verba, até enterrar um programa atômico que o Collor fez, eu lembro muito bem disso, encerrando um programa nuclear. Estão lembrados disso? Nós precisamos do Brasil de ter um programa, um plano de Estado, não de governo. Cada governo, em 4 ou 8 anos, vem, coloca o seu desejo ou não, libera mais verba ou menos verba. Quando nós ficarmos assim, os nossos programas aeroespaciais são do sistema vagalume, acende e apaga. Estou falando bem claramente o que eu estou acompanhando em 40, 60 anos de acompanhar esse sistema. Eu queria uma resposta. Nós precisamos batalhar para um sistema de Estado, programa de Estado, e não de governo.
Thank you, sir. I agree with you. That's why we changed the way we work. That's why we created the CCC, the Commission, and that's why we made a strategic program, long-term program. It was released in the 2012, and this year it was updated, maintaining the head. And that's why we thought about creating a company more than a decade ago, and we have been able to approve it by the Congress this year. So I think you are right, and we are in the right path to build long-term partnership between the government and the private companies, the commercial companies. Because it was said here, even the US took advantage of the arising of the private companies. So that's why Brazil was aiming that way. So we changed the 100% of government budget to try to explore the commercial companies and bring those benefits to the space program.
Excellent. Let me, okay, microphone there. Just comment this question as well, because this is very important. Has been working in the space program for more than 40 years. So, of course, he knows all the development of the program, or the lack of development, because we were pretty much connected with the government budget. So the industry was not participating directly with this. And this consideration is really important. So when I was in the ministry, I started certain new ways of thinking our space program, bringing more the private sector, and also the legislation to allow this to work. So as I said at the beginning, nowadays we have the law of space here in Brazil. It facilitates the participation of the private industry, separating military, civilian, private, government, and all this give much more ways for the companies to work in Brazil and to develop the products and services here. It's really important. And also about space applications, that kind of application can drive the revenues in the small companies, the startups, including artificial intelligence, which is the topic for our next presentation. But no doubts that working the way we were before was very difficult to develop the programs here in Brazil. The space program and the nuclear program. Now we have the laws to bring the private sector to work together, and this would be much, much more effective here in the country. Now, just, okay, you have there? Oh, he's going to answer.
My simple question is in English. I want to know about you, where you study, in what Air Force school? Where you study when you was young?
Where did I study? When I was graduating in the Air Force Academy. But I was raised in Brasilia, and then I entered in the Air Force Academy. And then I graduated from there. I became a fighter pilot, and a few years later, I went to our test pilot school here in Brazil.
Okay, thank you.
Welcome.
Any more questions? There's one back there. See there?
At some point of the presentation, you talked about how you use the technology to monitor criminal activities. And as far as I know, if I'm not wrong, it's a big challenge in the monitoring of criminal activity with the time resolution. Because sometimes a crime that's happening right now might not be happening anymore in a few hours. And usually increasing time resolution just with satellites, for example, is pretty expensive. How does Brazil deal with this problem to monitor criminal activities in due time?
Yes, you are right. We have to be as quickly as possible to catch them, but we can study their operations and their patterns. And Brazil has defense operation running right now in the north part of Brazil, so we can provide the information we have to this joint command working there. We can study how do they operate, which places they hide their assets, and we can find them. That's why artificial intelligence is so important, and to have a quick loop for us as soon as possible, it's very important.
Okay, so right on time. Thank you. Thank you. Thank you very much, but don't go away. We're going to call it back here too. Thank you.
And to conclude this inspiring morning, we have the privilege to invite the General Coordinator for Digital Transformation at the Secretariat for Science and Technology for Digital Transformation, SETAD, of the Ministry of Science, Technology and Innovation, MCTI. She will present the topic, the Brazilian Artificial Intelligence Plan, Opportunities for the Aerospace Sector. Please welcome Cristina Shimoda Weshi.
Thank you. Thank you, everyone. I'd like to thank you for this opportunity to be here today. It's a great honor to be in front of such a distinguished audience. And also, I'd like to thank you for my former boss, the astronaut Max Pontes and former Ministry of Science, Technology and Innovation. I work for the Brazilian state and not for the Brazilian government, but of course we work for all ministers that come here, and we also have the history of all these actions, programs, and that has been released. I also would take a moment to apologize myself because I will not be present in any technology program or institution so interesting for the space sector as the previous speakers. I'm going to talk our view of AI in a more strategic way and how we are shaping the future of AI in Brazil. Last year, Brazil launched its national AI plan, a bold initiative to transform the lives of Brazilians through sustainable innovation powered by AI. The plan was built through a highly participatory and inclusive process involving experts from government, academia, industry, and civil society, in collaborative workshops and consultations. Brazil recognizes AI as a powerful catalyst for socioeconomic development. We aim to leverage our unique strengths, a young and tech-savvy population, a high level of digitalization of public services, the diversity of our national data ecosystems, a clean energy matrix, and a strong research and development base. However, we also are aware of our challenges, such as the need to expand investments in infrastructure, research and innovation, ensure data interoperability and reliability, strengthen talent development and retention, and consolidate an effective regulatory and governance framework. In this context, Brazil's visions of AI for good and for all promotes a human-centered and inclusive approach, grounded in dignity, social rights, cultural and regional diversity, and the value of work. Our goal is to address social, environmental, and economic challenges, contributing to people's well-being and to the achievement of the Sustainable Development Goals. The Brazilian AI Plan will build national capabilities and expertise, aligning with initiatives such as the New Industry Brazil program, while fostering both digital and green transitions. We are committed to ensure that AI is transparent, traceable, sustainable, and responsible, safeguarding data privacy, cybersecurity, consumer protection, and national sovereignty. Finally, we envision AI as a bridge for global cooperation and fair, mutually beneficial partnerships. To realize this vision, the AI for the Good and for All plan is structured with 54 strategic actions distributed across 5 pillars: infrastructure and AI development, talents, digital government, AI for business, and support for the AI regulation and governance. The investments outlined in the Brazilian AI plan for the next 5 years total approximately 23 billion reais, equivalent to about $4 billion, which is a significant commitment within Brazil's economic context. So far, 6.6 billion reais, about 28% of the planned resources, have already been invested, demonstrating the government's strong commitment to putting this plan into action. During the plan's design phase, we identified 31 ongoing AI initiatives already addressing key challenges in areas such as healthcare, agriculture, environmental protection, and social development. These actions were classified as immediate impact actions. The second group of initiatives, called structuring actions, is organized around the same 5 pillars. Key features include the development of national capabilities and expertise, and ambitions and forward-looking vision aligned with industrial policy, a focus on sustainability and energy efficiency, and a long-term perspective that fosters systemic innovation that includes all institutions that has present previously. These initiatives span various levels of technological maturity and mobilize multiple disciplines and stakeholders. Under Pillar 1, related to infrastructure, we seek to equip Brazil with a state-of-the-art technological infrastructure. This includes the developing of a supercomputer powered entirely by renewable energy, a sovereign cloud, a national AI infrastructure, and also a network of AI centers of excellence to make research and development. In the aerospace sector, these investments will enable advanced simulations, satellite modeling, critical component design, and spacecraft development. We are also empowering Brazilian institutions such as INPE and the AEB, which have already shared their vision, to enhance their observational networks and data governance models, benefiting society as a whole. By combining AI, data, and sensors, we will expand applications in Earth observation, environmental monitoring, drone operation, and urban air mobility, areas that directly interface with the aerospace technologies. In the AI dissemination, education, and training pillar, Brazil is investing heavily in human capital. We are creating AI-focused undergraduate programs, scholarships, professional training, and ICT residency programs to increase the number of engineers, data scientists, AI specialists, and experts in simulation and embedded systems. In the next pillar, related to the public services, we are developing a unified government AI platform to apply AI solutions in health, agriculture, education, and public safety. We are also establishing a sovereign cloud for the protection of sensitive data and training public servants to the use of AI for process optimization and evidence-based decision-making. On the next pillar, related of AI for business and innovation, our goal is to strengthen the AI value chain in Brazil. We are supporting data centers, AI startups, and small and medium-sized enterprises, and channeling resources to AI projects in industry. This pillar is aligned with the Brazil's industrial policy, the so-called New Industry Brazil program. One of its missions focused on developing strategic technologies for national sovereignty and defense, reinforcing high-tech industry and reducing external dependence. Priority production chains include satellites, launch vehicles, and radar systems, all keys to strengthening Brazil's aerospace capabilities. And finally, the last pillar aims to establish a robust AI governance framework and balances innovation with rights protections. In conclusion, the success of Brazil AI plan depends on collaboration across all sectors, government, academia, industry, and civil society, at both national and international levels. We therefore emphasize the importance of international cooperation, not only with countries of North America, Europe, and Asia, but also with our colleagues from Latin America and Caribbean and the African countries to develop technologies that address global challenges and truly embody the principle of AI for the good and for all. Thank you very much for your time and for your attention. It has been an honor to share this vision with you. Thank you.
Well, thank you much. You see, artificial intelligence is being in all over, and here in Brazil, we just passed in the Senate the bill, which is a regulation for artificial intelligence here in the country, and now is in Chamber of Representatives, and hopefully next semester we are going to have this bill or this law approved here in Brazil, which will facilitate again the businesses and the development of artificial intelligence. So it's a huge topic that we can talk a lot about this, but I'm open for questions here to Dr. Shimoda. Please, there's one there.
Reinhold Ewald from Germany. Hello. Thank you for the talk. Well, we are all aware that AI can be poisonous if it is flooded by wrong perceptions from trolls, from institutions sending billions of emails and billions of comments. How do you safeguard against your AI use being contaminated by this bad influence? I saw some indications. You said critical use of AI. That's what you are teaching in your education program. And you said transparency and trustworthy of AI. How do you want to establish that?
Thank you for your question. We are a little concerned with all these points, and we have planned an action to establish a Brazilian AI Center of Transparency Algorithm, and like the AI Safety Institutes that has been established in other countries, and also as the European Center for Algorithm Transparency. But we are now discussing how is the Brazilian model. We are talking with many countries from the so-called global south, because we would like to make sure that we are contributing to the global AI governance and bring the vision that the ones that are not the main developers of AI, but we are users, but also we want to develop at least or participate in the process of development or deployment of AI systems, and we want to make sure that the systems that we have we can have take the decision of how we can operate the systems, and that's what we call the digital autonomy or digital sovereignty. And because we think that although the AI is for all, some countries and some companies are trying to take the decisions for all the planet, and we just want to participate in this process. Thank you.
Any other question about this? Let me just compliment you some things here about AI, since I've been working with this long time, since the ministry and up to the Senate. About education itself, there's three major branches for us to be careful with AI, let's say, to think about and to develop. The first one, in terms of education, of course, is to educate the future professionals. They need we need professionals and experts to help us to develop the AI and to develop solutions using AI. So this is the first branch, which is important, the participation of the universities, so to have courses, to develop new courses, to be flexible enough for those courses to follow at least as much as possible the technology enhancements that we have essentially by minute. So this is the first branch. The second one is related to the population itself, because we already have AI working in so many different systems that we use day by day, and of course that will just increase, and the population must follow this as well. So for the kids, it's easier because they are born in a new era of AI, but for the older guys, it's important to follow this, to not be behind. And remember that being behind is very dangerous, including the problems with cybersecurity. So we need the older population to be to teach them how to use, how to live in a AI society. And the third branch, and this is more delicate to more sensible to treat about, is how to use AI for education inside education. From one side is really good because you can use all the capabilities of AI to give classes that are more interesting for the kids. You can evaluate if they are getting the content or not, if they are very excited about learning new things. Okay, AI can help a lot with this. Even giving to the kids like an individual education, so based on their talents or their weak points for them to learn. However, if they are so much in AI, using AI to substitute, let me give an example. So the teacher gives the kids an essay to write. And so they go to ChatGPT or other things and they prepare the essay there in ChatGPT. They are not learning. Because they need to learn how to organize the ideas and how to put the ideas on paper and write well. And in human beings, we are kind of lazy. For example, GPS, nobody uses maps anymore. So we just trust that the GPS is doing a good job. We just follow the instructions on GPS. Imagine we just follow the instructions given by AI in all aspects of our lives, especially for the kids learning. And this is something that we that work with education, we have to be very attentive, very careful with how to deal with this in the future. So just to complement some of the worries that we are having in the Parliament, and we need to address that day by day. So thank you, Ben. Thank you very much. This moment, I would like to call to the stage here our other presenters, our rector, Professor Lorenzi, and Almeida, my classmate, Rodrigo, and Dr. Shimoda is here already. So if you have any questions that you forgot to ask before for any one of them, this is the time to ask questions. If you don't have, I just want to thank you, all of you, for the presentations. And for sure, you have all the names, you have all the contacts, anything in the future that they can help, please feel free to contact them or contact us that we are going to contact them. Thank you. Thank you much.
Okay, we now invite the official participants of the Congress to enjoy lunch at the main restaurant of the Club Med Lake Paradise. But before, we have two warnings. The first one, during the lunchtime, we will hold the traditional pin ceremony of the Association of Space Explorers, ASE, a symbolic act that celebrates the unity and commitment of new members to the mission of inspiring the planet through science and cooperation. The ASE pin is more than a symbol. It represents the bond shared by those who, having seen the earth from above, understand the true greatness of what unites us all. Please note that this is a reserved activity intended exclusively for registered participants of ASE 2025. And the second one, in the afternoon, we will have a presentation in Russian. So for those who need translation from Russian to English, we ask you to take the headphones before come back to the room. For those who already have headphones, please let them on your chair. And if you don't come back to the afternoon session, please return to the same pickup location. We wish you all an excellent break and inspiring lunch. We will resume the open session at 2 p.m. Thank you.
you.